Thank you for beta testing the track parser. This overview video will give you a basic understanding of the track parser. The track parser's main job is to essentially reverse engineer a trip plan. In other words, once you've done your trip, you can break your trip up into legs the way you choose and get some basic data. Time, elevation gain and loss, altitude change, things of that nature, along with your munter rate. So that way, once you've finished your trip, you can see how that went compared to maybe a trip plan that you had already made, and it'll help you be more accurate on future trip plans. For people who are training, this is a good way to train for longer endurance style sports, long mountain bike rides, or trail running, and break up each section to see how you did from a time perspective, how much elevation that you gained, and that type of information. This allows you to not touch a device. No lap times or starting and stopping stopwatches or starting and stopping tracks to break up your legs. Just start your event, do your run, bike ride, ski tour, whatever. Finish your track when you're done. Go home, put it in the track parser, break it up into the legs you'd like to get the data for, and find out a lot of basic information. Let's get started with a demo so you can see how the track parser works. So we'll go with an overview so you get a sense of what the data is going to be like that you're going to get from the track parser once you've finished using it. So there'll be 3 files that come out. The CSV file is kind of unimportant if you know how to use a CSV file to get other data or make charts, then you have it at your disposal. But for most people, it'll be this XLSX file and this data JSON file that will be of more interest. So let's start with the XLSX file. This is an Excel file. It's essentially a spreadsheet. And let's open it up. And it'll look like this. Each row will be color-coded, similar to this. The color scheme is blue, gold, yellow, and then purple. And anytime you stop and use a keyword, that stop will be in red. As you can see, there's a red at the top of Whitehorse. Let's go through the data quickly that you're going to get out of the parser. So the date that the run or bike ride took place. The weather data has been shut off. For now, in the beta version, the weather data takes too long to pull out and the server crashes. That's more of a problem because of it's in beta right now, but that weather data will get added in the future, and it'll give you temperature, humidity, wind speed, wind direction, and the wind speed of any gusts. That will come from the nearest reporting weather station. So it's actually can be quite useful for ski tours and things like that. So we'll move on from there. The actual time of day that you started the leg, the time of day that you ended the leg. This time is corrected for your time zone and daylight savings time. Then the name of the start of the leg. This is a label that you will choose. The elevation of the start and the elevation of the end with the math done to give you the altitude change. The distance in miles, the time you traveled. The total ascent and descent is cumulative. In other words, if the leg goes up and down, It'll measure all the ups and all the downs and give you an idea how much elevation you actually gained and lost rather than just the altitude change. You'll notice then there's a column that called the Munter rate. For those who understand the Munter rate, you get your Munter rate of how fast you were traveling, the rate that you were traveling from the Munter method. And then another total ascent and descent. The reason why there's two data points of ascent and descent is because GPSs are notorious to have some error with elevation. So this pulls data from the Shuttle Radar Topography mission. And that also has some errors. So what it does is it gives you sort of two data sets with errors so you can better compare and get a pretty good idea of the actual ascent and descent. For runners, there's the mile pace. For mountain bikers, there's speed in miles per hour. That's also sometimes interesting for skiers. Direction of travel is the straight line distance between the start and the finish. What the direction is, it'll give it to you like north, northeast, east, southeast, south, and on. Then there's the average angle. That average angle is calculated by taking the altitude change and the distance. And what you end up with is the hypotenuse of a triangle, of a right triangle, and then with some trig, the track parser gives you the average angle. Now remember, there may be some errors on the elevation of the start and finish, and so the average angle isn't perfect, but it gives you a good idea of the average angle of the terrain that you were traveling on. This can be useful for ski tours, especially if you segregate a leg is just the downhill portion, kind of gives you an idea of the average angle. With the direction of travel, basically that gives you angle and aspect of the slope. Straight line distance, again, if you drew a straight line from the start to the finish, it's the distance between those 2 points, and sometimes it's interesting to see how much straight line distance you traveled relative to the actual distance you traveled, which is a data point you get in column J. And then finally, the end label, which again is the label you give the end of the leg. And then there's the running time. So the running time is just cumulative time. So at the end of this, you can see 1 hour, 21 minutes, and 49 seconds was the total time of this trip. So that's the XLSX file, and it's basically a spreadsheet, and it will open up in Excel, or it will open up if you have a Mac and you don't have Excel, it'll open up in Numbers. Now from there, where we're going to go is the data JSON file, which we're going to import into CalTopo. And I'll just show you what that looks like in our results, our overview results. And it's this file right here, the data JSON file. I'll just put it into CalTopo. And what this does is gives you essentially a simplified map version of the data. So this was the trip. The trip is broken up into legs. The legs are, the color code is identical to the color code of the spreadsheet. And if you click on a leg, we'll click on this one, it gives you your start point, your finish point, the time it took to do that leg, and then the elapsed time since the start. So you can get some basic data right on your map, and it color codes the legs so that you can relate the columns to the legs, or you can send these files to somebody and they can see the data if they're planning on a similar trip. It's a good way to share information. So that's the results that you'll get from the track parser. Let's do a little demo so that you get to see how the track parser works And first you'll start from this home page. This home page will have the tutorial videos, as you can see, and then you click on Program. Once you click on Program, you'll be able to upload your track. Now, there's only, not all tracks will work. The track has to have time. So just to give you a quick list, and I'll have a list of these on the home page of the track parser for you, of what devices and apps work with the track parser. But the CalTopo app and the Gaia app both work. They're GPX files. If you download, both work. In CalTopo, the JSON file will also work, but the KML will not. In Gaia, the JSON file, if you download the JSON file, that won't work. Garmin, the GPX file will work. Avenza, the GPX and the KML file will work. Trailforks, the GPX file works. Some notable exceptions of things that don't work is the free version of Strava. Strava's free version does not come with time information, so the track parser can't pull the data out, give you your time and things like that if it doesn't have the time data in the file. So some apps work real well, others don't. Those are the ones that I know of that do. Hopefully you'll try some others, or you can send me some data if you'd like as you do the beta testing, and I can check out to see if it works, and we can get a better list of which apps and which devices work and which extensions from those devices work. So let's start out. What I'm going to do is first upload a file. So I have a file here. I'm going to actually remove the overview file just so it's not confusing, so we have a nice clean start. This was downloaded from Gaia, and it's a GPX file. So what I'm going to do is import that into the parser and upload it into the program. And what that'll do is change page, and it'll give you this, ask you to download what is called a smoothed or simplified file. What track parser does is it takes the data that you give it and it simplifies it a little bit, so that way there's not as many track points, because the track points oftentimes aren't that accurate, especially if there's a lot of them, and in particular if you're going slow. So if you're doing, like, post holing uphill, there'll be a lot of errant waypoints. This will smooth that out and give you better information. So we're going to get a visual of that. So what I've done here is I have the CalTopo open, and I'm just going to delete all the original tracks that I just gave you in the overview. I'm going to delete those objects, and I'm going to import what track parser just gave us. So when you go to the file that you have your original data in, there'll be another file now called a smoothed JSON, whatever you name the file, and then with an add-on that says smoothed and JSON. So what I'm going to do is put both of those into CalTopo, and we're going to compare the smooth one a little bit to the original, just so you can see it here. And I'll just unclick the original, and you can see how that they're like these little errant zigzags. And this was going uphill on a bicycle, so I was traveling pretty quickly. If you're traveling slower, there'll be much more of this zigzagging, which throws off your distance and to some extent your elevation. So you can see how it cleans up the track. All right, so now that we've got the cleaned up track and the original track in CalTopo, what we're going to do is add some waypoints. So the first thing I'm going to do is go to the start. So this was this was started right in this area here. And I'm just going to add a waypoint and label it whatever I'd like. So what I'm going to do is label this just basic start. All right, and then I can break up this trip any way I'd like to. So what I'm going to do is go over here. I follow some trails. It's pretty flat. And there's a logical spot right here where I get onto a paved road. And like I said, this was a mountain bike trip. And I'm just going to call this Hales. And then from there, I'm going to go to the top of Hales where there is, where I re-enter the woods and back on single track. And I'm just going to call that the top of Hales. And we'll add a couple more waypoints here, and then we'll move to see how the track parser works. So right at the top of Whitehorse, I took a little break. I had a bit of a transition. I had to change my helmet around a little bit, things of that nature. So what I'm going to do is I'm going to click back on the original, and you'll see that there's this, I call it a dither, where the GPS just sort of bounces around. This is the errant waypoints. It's not perfectly accurate for every track point, so it looks like the GPS is moving around. This, for instance, on a long rest, will set you up such that it'll look like you've traveled much further than you actually have. So by zeroing this out is pretty important to get accurate data. You can also measure the amount of time you stopped, which can be useful if you're a ski tourer and you want to know your transition time, or on my mountain bike, if you're an enduro racer, there's this, you know, like how much I rested before I hit my downhill, sort of gives you an idea. It's oftentimes just nice to know how long you stopped relative to how much time it actually took you to do the track. So for whatever reason, if you want to segregate your stops, what you can do is I'm going to add a marker right before the stop, and I'm going to unclick the original here. You can see it's just the one kink before, and I'm going to put rest. And then I'm going to use a key phrase. The key phrase is really important. It tells the track parser that the next section is a rest, and it zeroes out all the data except for the time. So what I'm going to do here is use the phrase, and it's going to be in parentheses, fixed or fix stop. In other words, fix the stop. And that will tell track parser to do certain things. So I'm going to add that. And then on the other side, and I want to see where that dither ends, you can see it ends right here. So I'm going to add another waypoint. And I'll just name this one start of descent. And what this does by putting a waypoint either side of the stop, it segregates the stop, and it'll give me the amount of time that I was stopped. It will also change the color of the road to red and change the track segment on the map in the data JSON file to red. Okay, so that's how you just add waypoints. What I've done here is I've already added all the waypoints. You can see I added a few more here, and I have one either side of that rest, just like I did before. And what I'm going to do is I'm going to export all that as a JSON file, GeoJSON, for the full backup. That's important. I'm going to export that. And then I'm going to go to my parser, and I'm going to put my waypoints in. So now it's asking me to upload my waypoints. So I'm going to go there, and here's my JSON file. I could have named that a little different, like my waypoint file or something along those lines, however I wanted to. But I'm going to upload that. I now put it in the parser and I upload it. This is where the parser is doing all its work. And now it's ready to download the results. I'm going to click download. And when I go back to my folder, I'll have a folder that's called results. When I click open the results, you'll see the data. So now I have my XLXX file and I have the Data Johnson file, just like I did before, and I can start looking at the data. It'll be exactly like I put out in the overview. And so now this gives you the information. You can save it and go through it, kind of get an idea. So that's the basic use of the track parser. There's a couple of things that are important. This was a circle trip. There and backs, you have to be really careful where you put your waypoints so that you don't reverse it. Put a waypoint coming back when you wanted to put it forward, because that will create an error in the track parser. If you have more complex tracks, let's say an alpine climb, where you were moving very, 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 very slowly up sort of a technical section of ridge line or something like that, the GPS will dither quite a bit. The track parser is set up to fix that. And also, if you've done some trips that you do continuously, like for instance, this cliff trip of mine, I do pretty regularly. And if you do something regularly, you can save the waypoints and reuse those waypoints for each trip and break up the trip into the same legs each time. So that way you can compare one trip to the next. So these little tips and strategies for how to use the track parser will be covered in future tutorials to give you a more detailed methodology of using it, so you can get the data exactly the way you want without errors and have good information for future trips, for planning, and for your training regimes. Thanks again for doing the beta testing. I really appreciate it, and I would encourage you to first use the track parser on simple trips, and then look at future tutorials or look at the more advanced tutorials and start using the track parser for more complex trips, so that way you can get the information you want. Thanks again. Have a great day.